Figure 3 shows a sketch of part of the curve with the equation y equals 6 over e to the half x plus 4. I need to use the substitution u equals e to the half x to show that the area of region R can be given by that integral there. So we'll start off with the way we would calculate the area under the curve, which would be the integral between our lower limit of 0 and our upper limit of 2 of y, which is the 6 over e to the half x plus 4 with respect to x. Now we're going to use the substitution to try to turn that into this. So we'll start off by differentiating our substitution. So u is e to the half x. So when I differentiate that, I get du by dx. The exponential differentiates to be the exponential, and then I times by 1/2 because of the chain rule. Making dx the subject now then. So I will times both sides by 2 to get 2du over dx. And then I will times both sides by the dx. And then divide both sides by the e to the half x. So I'm going to replace the dx with 2du over e to the half x. Now making sure we go completely over into the u world, we have got the e to the half x here and then e to the half x here. Both of those can be replaced with u. And we need to make sure we change our limits as well because they are currently in the x world. So when x equals 0, u equals e to the 1/2 of 0. So e to the 0 is 1. When x is 2, u equals e to the 1/2 of 2, which is e to the power 1, or just e. So our lower limit is 1, and our upper limit is e. Timesing those two fractions together, the 6 times the 2 is 12, and the u plus 4 times the u is u plus 4. And there we go. That is part A of this question done. Making sure you show all of those steps in your answers. And we're now going to move to part B, where it says, hence use algebraic integration to show that the exact area of R is 3 ln 5e over e plus 4. So to do this integral, we want to split the 12 over u times u plus 4. We want to split this up into partial fractions. So I'm going to write this as a over u plus b over u plus 4. So that's going to give us 12 is equal to a times u plus 4 plus b times u. If I let u equal 0, then I get 12 is equal to a times 4. So a is 3. Then if I let u equal minus 4, I get 12 is equal to minus 4 times b, so b is minus 3. This is now ready for me to integrate. So the integral from 1 to e of 3 over u minus 3 over u plus 4. The 3 over u will integrate to be 3 ln u, and the 3 over u plus 4 will integrate to be 3 ln u plus 4. Substituting the limits in then, so the upper limit is e, so we'll get 3 ln e minus 3 ln e plus 4. Now substituting the lower limit in, which is 1. So 3 ln 1 minus 3 ln 1 plus 4. Now simplifying this, the ln 1, I know that is 0, so I don't need to worry about that. But I do need to worry about the minus 3 ln 5. So that will act as a 3 plus, as a plus 3 ln 5. I'm going to factorise that 3 outside. And using the laws of logarithms here, in fact, what I'm going to do, let me rewrite the two positive terms next to each other just to make this super clear. We've got the ln e plus the ln 5 minus the ln e plus 4. And the point then is that because these two are being added, we can use the laws of logarithms to multiply their insides together to give an ln 5e. And then because we're subtracting the ln e plus 4, we'll divide by that, which is giving our answer in the form that we needed to show.